How's it going, guys? And in today's video we're going to be looking at how we can graph quadratic functions, such as what we have here, where we have y equals x minus 2 in brackets times x plus 4 in brackets. Now the first thing to notice here is that this is in x-intercept form. That is, we can easily find the x-intercepts of this function. And as you know, x-intercepts occur when y equals 0. So therefore, it will be 0 equals x minus 2. And then solving for x, using the null factor law, we get x equals 2 or minus 4. Therefore, there are two x-intercepts. So if we put label there we are. Now, the next thing to find when graphing any function is the y-intercept, and it's a necessary part in order to get the function right. And to find the y-intercept, it's simply letting x equal 0, because y-intercept is along this y-axis, and it's when x equals 0. So doing that, we get y equals 0 minus 2 times 0 plus 4, so therefore y equals minus 8. So if we go 1, 2, 3, 4, 5, 6, so that's the y-intercept. But notice that this will not be the lowest point. So therefore, we need to find the vertex of this function. Now, since this is in x-intercept form, the vertex can simply be, the vertex is the lowest point, because it's positive. This is plus 1 there. The graph has a minimum, when the vertex is minimum, in other words. So that means the vertex is going to occur right in the middle of the two x-intercepts. So it's going to occur at the x coordinate that is right in the middle of 2 and minus 4, which is in this case it's going to be right in the middle here. Sorry. Now, right here, minus 1. Now we simply, to find the y, or to find the vertex, we simply sub in x equals minus 1 into this equation. So y equals minus 1 minus 2, and this will give us the y coordinate for the vertex, or the lowest point of the function. Minus 1 plus 4. Now this equals minus 3 times 3, which equals minus 9. So therefore the lowest point occurs just below the y-intercept at minus 1 minus 9. Now to graph it, we can simply join all these points together with a smooth curve. Something along the lines like this. And we add arrows on the end, because to acknowledge that this will go on infinitely. Now, if we have a look at another example, in this case we have y equals x plus 2 squared. This one's a little different in that it's just, rather than having two different brackets, it's just one single bracket, but that changes nothing. So if we want to find the x-intercept, we just let y equal 0. 0 will equal x plus 2 squared. Now we can solve for x. X plus 0 equals x plus 2, therefore x equals minus 2. But the thing that's different here is that it's only going to hit the x-axis once. That is, it has one x-intercept as we solved here, rather than having, let's say, -2 and 4. The next thing to do is find the y-intercept. So doing that, we have to let x equal 0. So y will equal 0 plus 2 squared, y equals 4. So therefore, the y-intercept is y equals 4. Now notice that this x plus 2 is the vertex in this case, but we need another point in order to draw a quadratic graph. That is, we need 3 points to successfully and accurately sketch this function. So therefore, if you're stuck in this case, you sub in any random x value. So in this case, I'm just going to sub in x equals -4. Let's see what we get. If we say y equals -4 plus 2 squared, we get y equals -2 squares, which will simply equal 4. So that means we get another point there, and that means we can accurately draw the graph. So we just want to draw a light sketch, something along the lines of this. Notice that that will go on forever, so we simply add arrows. Now in this final case, it's looking at something a little bit different. This function's written in what's called a vertex form. That is, we could have had a function y equals x squared plus 2x plus 7, and simply just complete the square to get it in this form. And straight off the bat, this tells you what the vertex is. Because consider x minus 4 squared. The vertex will be the x-intercept, which is x equals 4. But we're moving it up 2 units. So therefore, the vertex of this function is going to occur at 4, 2. Simply moving the previous vertex up by 2 values, or 2 units. Now next, like always, we need to find the y-intercept, which we do by letting x equal 0. Notice that this will not have any x-intercepts because it's been moved above the x-axis and therefore will not cross at any point. So solving for the y-intercept, we get y equals -4 squared plus 2, which will equal 18. So if we count up here, 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18, that is where the y-intercept goes. Now, like last time, we only have 2 points, but to draw a quadratic function, we need 3. So therefore, you sub in any value you want. So in this case, I'm just going to sub in x equals, let's do x equals 8. If we sub in x equals 8, we get y equals 8 minus 4 squared plus 2, which means y equals 18. So x equals 8, y equals that, and therefore we can just draw a sketch connecting the points as such, with the arrows on the end indicating that goes on forever. And there is the quadratic function y equals x minus 4 squared plus 2. And I hope this helps.